Maha, any idea how many people we might be expecting today?
Yeah, we're just gonna wait for a few more minutes and hopefully there will be like around 20 people.
Awesome. More pressure.
I think you're gonna do great. I mean, I know you're gonna do great.
Thank you.
Hi everyone, we'll get started in the next 2 minutes. I'm going to go ahead and send a sign-in link so you guys can sign in at this link, and the secret word is sector.
Hi everyone, thanks for getting here on time. I know the week must be getting pretty busy with midterms and everything, so we're glad you made it out to this workshop. So let's jump into it and get started. So I want to welcome everyone and also JPMorgan Chase Executive Director Mimi Park, who is going to discuss artificial intelligence, machine learning, and data science. She has been involved in data science and machine learning for the past 8 years, so we know she is an expert who can tell us all about the hype. We are so thankful to have her here today as a speaker. This workshop is going to be recorded and it will be posted on the WEHack YouTube channel. Along with that, I just want to let you guys know that there is the signing link in the chat, so make sure you are signing in to get a sweet star point. And with that, Mimi, I'm gonna pass the stage on to you and you can kick it off.
Okay, hello everybody, good evening. Can you hear me okay? Okay, I see some nods. Excellent. So first of all, thank you for the WEHack organizers for inviting me, letting me share my views. It's been a long time coming. I think we first said it was going to be earlier this year and it got pushed out. But a lot of kudos to Maha and the rest of the team for being patient with me, trying to get all this coordinated. So again, you guys are really amazing group of people. Quick introduction about myself. I've been in the data science field for over a decade, so coming around, 13 years now. So I have a few things to say about it, and I'm so happy to get to share with you today. And what I'm going to explain today at a high level is artificial intelligence, data science, machine learning. So these are all big buzzwords, today. And as I was thinking about my topic for, this session, I thought it would be beneficial for, really two reasons. First is that it's a very hot field. There's a lot of demand for talent in this field. So I thought it would be, beneficial for you guys to learn about what it is about, how to get into it, so that you can be a little bit more informed as you start thinking about your future career path. And then second of all, as hot of a field as it is, there's a lot of things out there. There's tons of material on Google and whatnot, and it can get very overwhelming in terms of just understanding what it is, and there's a lot of different opinions and paradigms out there. So just to add to the confusion, I'm going to try and explain what my views are on it, and hopefully just kind of contribute a little bit here. So I have a presentation. I'm going to share it, so give me a nod when you see that. And I'm going to do a big slideshow. So is that, I have a ultra wide screen. Is that showing up okay on your end?
Yeah, it looks good.
Okay, excellent. So, this is the topic for today. With my introduction, there is no one interpretation about this topic that is going to be the end-all, be-all. Like with anything good, the way that people define and organize this topic is extremely diverse. So I want to give you a friendly disclaimer that, again, the way I'm describing it is the way that I view it, for, how I think is kind of the easiest to understand. Everything is debatable, that I put out here. A lot of the content here is not my original creation. It's some of the most popular paradigms out there. I'm trying to add my color and kind of context to it. So, as well as give a practitioner's perspective. What I can promise you is that I'm going to try to make it as simple as possible. My philosophy is that I want to be able to explain it to, a 6-year-old or my grandma, and they will get it. So I hope that, what I've prepared today will really resonate and help you understand this domain. So without further ado, all right, so let's first define a few things. AI is it's been going through such phenomenal changes in, the last decade or so. And, it started out as a purely kind of academic and research domain, and we've seen, widespread industry adoption across many, many different domains, including retail, technology, healthcare, you name it. And the key objective of AI in the 21st century has been solving real-world problems. It is automating complex tasks behind the scenes at a company. It is making our lives easier and better. It's helping companies, save costs and, generate more revenue. So it's been a there's been a lot of hype about it, and for very good reasons. So to define AI is any technique that enables computers to mimic human behavior. So it's a very broad term for machines or computers to be able to do tasks that we might consider smart. So if you look on the circle on the left, those are some of the kind of the subdomains of AI that I included. It includes computer vision as well as speech and audio. We're probably really used to that. Machine learning, the language understanding, and so on and so forth. So a subset of that is machine learning. You cannot ignore that. And machine learning is one of the most popular applications of AI today. And basically, it is a set of algorithms that learn from data using statistical algorithms. And then it applies what it's learned to make informed and smart decisions in a future scenario. In many ways, I see machine learning as a way to mimic the human thought process, right? How we learn a lot of times is through experience, and many experiences and observations that we make. To make a very simple analogy here is, and it's a pretty strange example, but I thought of the time that I was trying to potty train my dog when I first got her. So I got her as a puppy. She was not potty trained, of course. So I needed to, find a way to take her outside whenever I felt like she needed to go. And I observed her extremely closely, and I started to kind of detect some of the signals that she was, showing before she would, have an accident in the house. And some of the things that I started to notice was her starting to walk around and sniff things a little bit. And, or it was the fact that it had been within 30 minutes of her having her last meal, or had been around, 3-4 hours since she had been last let out. So like when I combined some of these observations that I made, at the end of it, I was pretty good at, knowing when I needed to take her out. So, in a matter of a week or two, she was pretty, trained pretty well. So in that same way, machine learning intakes data, learns from that data, and it applies those learnings to future scenarios. And I'll get a lot more into, some specific examples. And lastly, data science is the practical application of advanced analytics, statistics, machine learning, programming, things like that, in a business context. So data science is the foundational capability that makes AI and machine learning work in the real world. It's the discipline and the capabilities that it ranges across the whole spectrum of data, from data storage to data engineering to visualization, statistics, programming, machine learning, and so forth. So it is the enabler of machine learning and AI, like a building block, because you need to, you actually build machine learning algorithms with those technologies. So if you ask me what data science is, I would say simply, data science is something that helps you get value out of your data. So this is just a different representation. It's more visual than what I just showed you. And data science is a very big, encompassing field. Everything about data, like I said, statistical modeling, programming, and so forth. And if I double click into that, you see where artificial intelligence and machine learning kind of all lays. So AI is the big domain that it's very generic, right? And then within this subset of that is machine learning, and then within that is deep learning. Now I'll get a little bit more into what deep learning is in the following slides, but I hope that this kind of helps you kind of place everything in one place. So more terms that you might have seen and heard. I think I'm going, pretty fast, so you got to keep up with me. So there's three major classes or types of machine learning algorithms. If you ask a scientist, they might say, no, there's actually, 15 of them, or 20 of them, or 5 of them, right? So, again, there's a lot of ways that people view types of machine learning algorithm, but these three are kind of the most kind of widely accepted, the biggest domains here. And so the first one is supervised learning. And supervised learning is the way that all of this is defined is it has everything to do with how we want the machine to learn. And supervised learning is where we are, as we show the computer more and more examples, we are teaching them what outcome is supposed to be correlated with that. So, for example, another analogy. If we think about how a toddler learns in their very early years, right? Likely, their parent has, opened up a book of animals and they pointed to a picture of an elephant and said, "Hey, this is an elephant," right? So it's telling them what the correct answer of that observation is. And then, they point to another picture and say, "Hey, this is a picture of a monkey," right? So then they do this enough times and they see a variety of examples of, monkeys and elephants and birds and whatnot. So then, as the toddler learns and associates these visual cues with the label of an animal, the type of animal, they can see a picture of an elephant that they've never seen before and still identify that correctly. So just like that, supervised learning is you are supervising the learning of the machine by telling them this set of data is associated with this label or output or an outcome. So two major classes of supervised learning algorithms is classification. Classification is when the outcome or the correct answer is a binary data or it's a categorical data, right? It's an animal, it's a monkey or it's an elephant. Or, in the case of banking, it's a fraudulent transaction, it's a non-fraudulent transaction. So there are very finite answers there. In a regression type of case, the algorithm is trying to predict a real number. A prime example here is for Zillow, right? If you ever, gone on Zillow.com, it is a website that lists all of the houses and properties for sale. And if you click through some of those properties, you will see something they call a Zestimate or a Z-estimate. And that is run by a machine learning algorithm, the back end, that takes all of the different characteristics of that house that is documented. And it takes the data of all of the houses nearby that has been sold recently and starts to correlate that with the characteristics of those houses. And it's able to make a pretty reliable prediction of what the particular house is going to sell for. And instead of the machine learning algorithm predicting some sort of category of some label, it is predicting a particular number. So that is what a regression machine learning algorithm is. So when it comes to unsupervised learning, we're not necessarily telling them how to associate the data with some sort of outcome. We are just dumping the data into an algorithm and saying, do what you want to do with it. So back to the toddler example, we can imagine the parent giving them a bucket of blocks. And we're saying, hey, try to organize these blocks the way that you want. Make different piles of it. And then the toddler might, start to make different piles of blocks by color, or it could do it by size, like maybe different shapes. So, it's just trying to organize the data in meaningful ways. And an unsupervised learning algorithm does just that. And so clustering is a algorithm where it groups the different observations and data points in meaningful ways. Anomaly detection, or they also call it outlier detection, they do it to find cases that just kind of seems really odd and unlike the other ones. And frequent pattern mining as well. This one is detecting patterns through things that occur most often together. Lastly, reinforcement learning is like a toddler learning, or baby learning how to walk, or an older child learning how to ride the bike. So we can't necessarily tell them explicitly how to learn how to walk or ride a bike. They learn by trial and error. They just start going at it. They start to remember what they've done to not fall versus what they've done to when they fell. And then they start to get better and better at it. So reinforcement learning is when an algorithm learns in real time through very explicit feedback on its own. And a very good application of reinforcement learning. It also does, classification problems and whatnot. But, self-driving cars or running and walking robots, those types of things, as well as algorithms that have played games or chess and won against, the best opponents in the country. Those are learned by reinforcement learning because they were able to just try different games and they learn by either losing or winning the game or, falling on the ground and things like that. Oh, by the way, something I haven't included in here is that is where you give labels or learned outcomes for only a subset of your data, and then the algorithm kind of learns how to apply that to all the other types of cases. It's a pretty kind of new field. I did not include it in here, but I just wanted to put it out there that that's also kind of a big class of algorithms. Deep learning. So let me try to explain this. Deep learning is a type of machine learning, as I've said in previous slides. It's a much newer application set of algorithms we haven't been able to do until recently because we had limited compute power. So compared to classical machine learning algorithms, it can predict with much better accuracy for much more complex problems. And an example of a very complex problem is image recognition. The reason for that is because when a computer interprets an image, how it does that is it has to translate that into data. So it's going to take each and every pixel. And so that's going to be a new data point, as well as the color spectrum for each of those. So that data just blows up really quickly, depending on the resolution of that image. So deep learning has been a very useful and a powerful tool to employ image recognition. So deep learning uses a set of techniques called neural networks, and that's very similar to how our brains process information. So because it is so powerful, it can handle a lot of information, millions and millions and billions of different rows, and it likes more information. And that is how, it differs from classical machine learning. Is that as you see on the chart on the left, as I have described before, the way that we learn and the machines learn is we like more and more examples of data, right? And so we learn better that way. But with classical machine learning, there is a point where you dump more and more data in it. You're not going to gain a whole lot of new learnings because these algorithms are relatively naive. So it doesn't have the depth of the problem breaking down all of the features that would make it extremely precise and accurate. But for a deep learning algorithm, the more and more data that you pump in, it's likely going to increase in accuracy. So that's been a huge kind of differentiator there. Another big differentiator between classical machine learning and deep learning has a lot to do with what we call feature extraction. So feature extraction is very important in terms of how well a machine learning algorithm performs. Machine learning algorithms are very sensitive and picky to what information is useful for training. So we, as data scientists or humans, we have to be intentional about what training information we feed into it, right? It's pretty sensitive to noise as well. And we have to also, in order for it to perform well, interpret how we have to present the training data. For example, if I'm trying to today predict what my house's worth is going to be next year, right? Instead of only telling it the face value of today's value, what it is worth today, it might be much more useful for the algorithm to know the percent change between last year and this year's worth. That might be a much better signal to know how much is going to increase into next year versus just having the nominal values of my house value. So there's a lot of art that goes into determining what type of data you feed into your algorithm, and it's very sensitive to that. However, with deep learning, it essentially kind of within the neural network idea itself, it essentially does the feature extraction for you already. So you don't necessarily have to employ so much art in trying to just pick out what you want to feed in. So again, it's very beneficial. It's much more accurate and handle much more complex problems. So you might ask, why don't we just get rid of the classical machine learning problems and we just apply deep learning everywhere, right? It's better, it's faster, whatnot. But I want to leave you with one important principle, though, which is, if you think about it, when it comes down to it, there's hundreds of different algorithms that can do the same thing. You lay it out all in one spectrum, with deep learning being on the very, very top end. There's a lot of them cross the spectrum. However, you don't always want to choose the fancier one. You want to choose, as a practitioner, you always want to choose at a reasonable, cost, the simplest and the least expensive to run. Because, as sophisticated deep learning is, one of the drawbacks is that when you apply a deep learning model and make a prediction, it's hard to understand why it made that prediction. So let's take an example in banking, right? So let's say we have a model that intakes a customer's application for a loan, and it determines whether the bank should extend that loan to that customer or not. So it's trying to assess the creditworthiness of that customer. So, you're going to feed in the details of the application, probably includes, the customer's income and their, credit history and whatnot. And it's going to assess, yes, you should extend the loan to this customer or not. Federal law in banking requires that when you deny a customer for a loan, that you have to explain why you denied that. And with classical machine learning, there's plenty of kind of native ways that you can discern what factors contributed the most to making that decision. However, with deep learning, it's so intricate, it's almost impossible to kind of undo that logic and backtrace retroactively how it made that decision. So you would not be able to necessarily use a deep learning algorithm to make a decision on a loan because you don't have the capability to explain why that answer was reached. So as practitioners, you always have to consider what type of algorithm among dozens and dozens is the most reasonable in terms of the type of accuracy that I need, the type of compute power that I have and how fast it needs to run, what type of output it needs to give, etc. So jumping right into the real world applications, I've laid out 4 main domains, and this is by no means representative of the whole spectrum of how AI and machine learning is applied, but just some of the representative ones. So the first is customer attrition. So for those of you that don't know what that means, customer attrition is when a customer ceases to be your customer. They either went to a competitor, or they have stopped the subscription, they stopped buying your products, etc. So it has a very direct impact on the company's revenue. And an interesting stat on the top you see is that on average 30% of customers are lost each year. And so if you think about it, every 3 or 4 years you would have a completely new set of customers. And so the more that you can decrease that figure, the more revenue you will get. So that's a big kind of initiative that companies are looking at. And one particular company, a telecom, they reduced their customer attrition by 30% because they used a machine learning model to predict customer attrition. So they looked at historical customer behavior and said, okay, well, they applied that to the current set of customers and said, these customers are likely going to leave in the next 3 months. So then they started to really proactively reach out to their customers. They started to fix their issues better and faster, give them white glove treatment. And they saw a huge kind of impact in terms of being able to keep those customers. The next big field is in personalization and marketing. So, as consumers today, right, we're extremely, spoiled. We want the companies to, appeal to us in the way that we want to be. We don't want to be shown and talked to in the same way it talks to everybody else. We want to, be seeing the ones that we can have instant gratification on. So we expect these companies to know us really well. And one of the biggest ways that companies do that is through product recommendations. So a big example there is Netflix, right? We all know Netflix is, we log on to Netflix, the moment that you log on, you're going to see a myriad of recommendations of movies, right? And that is all backed by very, very powerful machine learning algorithms that look at your previous watch history, as well as how customers like you have rated their movies that they've seen, and they are generating all these recommendations. And they were able to save $1 billion through just preventing customers from unsubscribing because they couldn't find a movie that they wanted to watch. Amazon is another great example. A third of their sales is generated by product recommendations that they show them through emails. There's always products that they show when you go to a product page or even on the home page. So it's an extremely significant driver of revenue for companies, and you cannot imagine them succeeding without using machine learning. And thirdly, operations. So operations really means that it's kind of all of the human capital, the machines, and all of those things that run in the background to make the company run well. And a particular company saved 360,000 hours of labor because they employed AI to do document reviews, whereas people used to do that before. AI is able to read fields on a page and sort it the way they need, as well as doing the employee IT support through chatbots. And they were able to save a lot of the kind of the call center agents because they had chatbots answering the most frequent questions from employees, as well as other back office functions. And lastly, fraud management is a very big field that is, powered by AI and machine learning. An interesting stat there is that 90% of transactions are approved following a manual review of the transaction, or a loan application, or something of that sort. And that stat means that we're probably reviewing more transactions than we really need to. Essentially, we're trying to find a needle in a haystack. So we're wasting a lot of time and effort trying to find something that is very, very rare in occurrence. So the idea is that, when a transaction or an application or, something like that comes through, you can run a machine learning algorithm to look at the characteristics of that and do kind of a pre-sort or a kind of a prioritization of which ones are likely going to be fraud and not based on prior information. A particular bank saw a 60% in reduction of costs from having to hire people to review everything because they employed a machine learning model. So the model was able to say, yeah, this majority of the files, it's so run-of-the-mill, you don't have to look at it, but these are the one that looks the most suspicious. So we're going to pass this on to you, the humans, the expert, that can really kind of make that final call. So these are some, major ways that machine learning and AI is being applied. And a quick note about this is that there's a lot of praise about the use of AI in the industry, but there's also a lot of negative media as well. There's talks of, AI kind of taking over the human race and, or sometimes AI kind of displacing the human workforce too much where, humans are losing jobs. And I think that that is true in some cases. Well, first of all, the AI kind of taking over the world and stuff like that, that is kind of so far-fetched at this point with the technology that we have. That's going to be kind of way in the future. But in terms of, displacing human labor, it is true in a lot of cases. But, we can kind of look at that in a different way. That is that AI doesn't necessarily have to be a human displacement component. It can be a human enhancement technology, meaning, prior to all of this coming about, humans used to be kind of on the factory floors on an assembly line doing very, very simple and repetitive work. But now, robots are doing all of that. So that means that now as people get to do more value add work, engaging and thought-provoking work, and work that is much more emotionally intelligent. And so it's leaving a lot of room to enable humans to do work that is more progressive and more research-based and a lot more engaging. So, the idea is that instead of doing the same thing with less people, right, AI enables us to do more with the same people. So I think, sometimes we have to view AI in that way, instead of just being, dismissive of it because of some of the negative connotations there. So, this is my last slide, and I was thinking, as I was preparing this talk, what can I leave you with that is, much more practical for you guys, instead of just leaving everything kind of pretty theoretical. And I thought, I could talk about a career in data science and what that looks like. And so, the most representative kind of job role in that field is a data scientist. And I thought this was a pretty good kind of layout of what some of the qualifications and the profiles of these roles are. And the first thing is the educational background. So the top 5 are computer science, business administration, statistics, mathematics, and physics. I myself have a degree in math from undergrad and a degree in statistics in grad school. And, lucky for you guys, I wasn't as lucky back then, but now there are, universities offering data science degrees. And they are combining all of the, different domains that kind of blend well together, like statistics and math and computing and business, to help people be more robust and well prepared for these types of roles. But you don't necessarily have to major in any of these to be a effective data scientist, but it will definitely kind of help you get noticed a little bit faster. And the top primary skills of a data scientist is data analysis, R, Python, data mining, and machine learning. So R and Python are really the hard skills that is needed. And these are the backbone of building an algorithm or doing a data analysis project. So programming is a big part of it. So having those skills will definitely get you noticed. In terms of the education level, the majority of current data scientists have, master's degrees or higher. But, as someone that has interviewed and hired a lot of data scientists, having a bachelor's degree is not so that much more inferior at all. And being a very good data scientist doesn't only mean that you've got all the hard skills in mind. To be a good data scientist, you need a lot of soft skills as well. So you need extremely good communication skills, people skills, presentation skills, critical thinking, and things like that. And so I would always much rather hire someone that is much more well-rounded in the hard and soft skills. And if that means that they have a bachelor's degree versus a master's, that's irrelevant to me. So I hope that's a little bit helpful. In terms of the industry growth, like I said, it's such a hot field right now. There's a lot of hiring of data scientists going on. At the same time, there's a lot of new grads coming out with data science degrees, but I do not think that the supply of data scientists is going to meet the demand. So it's a very, very promising field to get into. And lastly, the top industries that are employing data scientists are IT and computer software and things like that, of course. But the great thing about data science is that it's industry agnostic. Virtually every industry that you can think of are they're leveraging data in very creative ways. Like I said, in retail, I had a stint a few years in retail as a data scientist where I was building product recommendation algorithms and models to predict with designers which brands were going to sell more, so then the buyers can go and invest more in those types of products. So, if you have a particular passion in a field, then you don't have to give up, being a data scientist to do that. So it's kind of the best of both worlds. And, I started out as a data scientist, kind of evolved into a more of a leadership role today. But, in my experience, it's been something new every single day. You work with a lot of internal clients. Some clients, want to help. They need help to sell, market to their customers better. Some want to build, better risk models, and you name it, there's everything. And there's a lot of appreciation of data science, talent in companies. So definitely something that you can look into if you are interested in some of the skills that we talked about here. So with that, I'm not sure kind of what the format of it here is, but I thought I would leave some, a few minutes for questions. So open floor or however you guys want to handle that. Ashana?
Yeah, so I guess we can just let everyone, if anyone has a question, you can unmute yourself or you can ask it in the chat.
Hi, I have a question.
Yes.
What do you think is the most fun or rewarding part about being a data scientist?
So just to repeat your question, most fun and what's the other part?
Or rewarding?
Gotcha. Just piggybacking on what I just ended with. As a data scientist, you're not. So data is extremely kind of agnostic to type of business problem, right? So you get to work with a lot of different types of clients. So even in a particular company, even in banking, we get requests from a lot of different business units, like risk, marketing, operations, and so many recruiting, HR. Sometimes they want some data science help. So you learn many different aspects of a company, how it runs and what's kind of the thought process and how they improve the work that they do. Because you need to kind of download their thought process and put that into your models. So it's a constant just cycle of learning. And again, the fact that you can go from being a data scientist in retail to healthcare to aerospace to banking, what have you. So just the fact that you're not just tied to one specific type of business, I think it's very rewarding.
Okay, thank you.
Okay, I think I've seen some questions come up on the chat. All right, Rochana, do you want to maybe just select some of them and just call it out, because maybe you can do a better job thinking and reading at the same time. I don't have that.
Sure. Yeah, so we have a question from Mike who asked, do you use cloud platforms? If so, what is the most common cloud technologies we should learn?
That's a great question. And the answer is yes. So fundamentally, you can have your Python or your R installed on any machine, whether it's on the cloud or on-prem. Cloud is making big strides in the industry, so a lot of companies are now moving on to the cloud. So as a data scientist, or in the data field period, it's very useful to learn the cloud technologies. Cloud is very beneficial for the fact that you don't have to buy a very set piece of hardware and try to make that work for everything. Sometimes you have very high volume and where you need to process a lot more information than other times. And if you are on-prem, if you're not on the cloud, then you have to always kind of buy for the maximum possible things you need to do. But for cloud, you can just pay for literally that moment how much you need for it, and then just not pay for that type of server, that type of machine, that type of algorithm, so forth. So AWS is very big. They've always been a leader in cloud. And the great thing about most of these cloud platforms is that they come with a suite of machine learning algorithms and a data science developer bench, kind of a workbench environment. So you're able to kind of grab data from virtually anywhere that is connected on the cloud and bring it into your data science workbench and start, working on it instead of having to create so many hard connections from server to server and to machines and stuff like that. So I really encourage you guys to look into all the different kind of packages that AWS and Google Cloud Platform and Azure offers as part of their data science offer.
Okay, I'll take over for the questions now. So it looks like the next question we have is from Kevin, and he's asking, okay, so he said the top industry employing data scientists in slide number 4 was education. So would you give us an example of where data scientists are needed in the education sector?
Great question. So I was, to be very transparent, kind of surprised about that because, you think education, at least public education, is kind of, not well funded and things like that. But I think universities are using data a lot to, make sure that their students are very successful, that they're recruiting, top talent, that they are tracking student performance very well. And so I think I haven't actually done a specific project in education, but some of the, major use cases I've heard in education is, looking at factors that help kind of produce really, really good teachers. So what characteristics of a teacher helps students earn higher grades and, better learning? As well as they do a lot of analytics on students, tests what kind of environment helps students, earn better grades on standardization, or what kind of places should they start to recruit students, to give them scholarships and things like that. So I think there's still a lot of opportunity. I wouldn't say that they're kind of a poster child for analytics, but I think it's very cool in terms of how they're leveraging data.
All right, cool. Okay, looking up, it looks like we have a question from Mark. So it says, I see a big need for people who are conversant in data science speak and business speak to help convey to the data scientist what analytics are needed by the business, and then explain to the business the results and how the model reaches the reached the predictions or results. Is that a defined role yet?
I love that question because that's exactly what I hope to articulate in my job descriptions when I look for a data scientist. Maybe it's not a data scientist, and to your point, is that a different role? Is that defined? And the question, the short answer is both yes and no. No, I mean it's not a very widely known role. Even the term data scientist is so broad nowadays. Facebook calls their data analysts data scientists, but they expect their data scientists to be a core part of their product teams. They are expected to work hand in hand with the product owners to say which features of Facebook is working very well for what reasons, needs to have these improvements, etc. But other companies, their data scientists are just really technical, and I see some companies struggling with really kind of seeing the full benefits of their data science talent because that translation is not happening. So there has been emerging kind of a new role, if you will, that is called an analytics translator. And, that is kind of for its namesake, like you said, they kind of understand the business priorities and how, what's the major objectives that this analytics product or machine learning product needs to meet. What are the risks associated with it? Who needs to be involved to make decisions around it? But they're also able to kind of do the technical speak, if you will, because they understand the different algorithms and what are the requirements for the algorithms. So they're able to kind of do exactly that. And there's actually a very, very good McKinsey article called something like The Need for Analytics Translators. And, I almost wanted to kind of directly put that article into my kind of job description because it articulated so well what is needed for a role like that, and I believe there's going to be a higher, much bigger need for those types of roles. Companies just don't know it yet. But honestly, the reason why I feel like I have, somewhat succeeded in my field is because I started to kind of build that bridge, fill that gap. So if you're able to do those, really go in between those two fields pretty well, then you might be very successful. Of course, you can be on the really technical side and be very successful as well. It's just a very different role.
All right. Okay, so the next question we have is from Sam. And she wants to know if someone wants to switch interest or role from software engineer to data scientist, how should they get started?
Yeah, I would say that the transition between those two would be, it's more natural than, a completely different role. So, I would say that it's a very good start. As a data scientist, you're still coding and you're building reproducible code. So I love employing software engineering principles into data science, where you are building code that is, you can build it very agile. You can kind of compartmentalize it and plug it into something else if you need to improve the code or something like that. But anyway, I think the coding part is probably becomes more natural. If you are able to code in Python, that's going to be a super easy sell. But on top of that, for a software engineer, getting a good kind of knowing the basics of what the different algorithms are, what the how to apply those algorithms. There's a lot of assumptions that we know need to meet about the data in order to just plug in into a machine learning function. So you can always put something in, but your output might be trash because you did not meet the right data assumptions. It needs to look a certain way. So you want to understand those nuances. So getting a primer on the different types of algorithms, like I said today, what's the different classes, when do you need to apply a certain algorithm in what case. So if you kind of have those basics, I think you can probably start to practice immediately and just get better.
That was really cool. Okay, so we have a question from Gabrielle, and she says, so she's currently a data science undergraduate major at UTD, and she's wondering what advice you have, especially with starting out in the field with internships. Because so far the most she's seen is internships for masters in data science.
I will preface this with the fact that I'm probably not the best person to answer this because I'm a total old dog, as I call it. I kind of got into the field accidentally, so I don't have kind of the latest and greatest tips. But as someone that does hire data scientists, internships are absolutely helpful, right? Because we want someone that doesn't only know machine learning from a theoretical level. And the reason why I say that is because when you look at a machine learning, a data science development cycle, you have to wrangle a lot of data. And it is absolutely true when people say 90% of your time and effort is spent on cleaning data, understanding the data, shaping it so that it fits the type of algorithm that you're trying to use. So a lot of that requires practical experience where you have actually looked through all of that dirty data. It looks different everywhere you go. And if an internship is going to give you access to a lot of real data and not just very, pristine data sets that you can download from like, a website or something like that, the more projects that you can speak to like that, I think it's going to really help you. So in terms of competing against someone with a master's degree, yeah, I think it's a little bit, hard. If they have the same exact qualifications or similar types of internships, that might be a hard sell, but I think when you get to an interviewing stage, you want to really emphasize not only the technical aspects, but that you are a critical thinker, that you kind of are able to work effectively with your business stakeholders, and you are able to kind of reason, like rationalize when to make a trade-off between two types of algorithms. Do I go for a very compute-heavy one, or do I go for something that is, more just quick and simple? Stuff like that. Those are all the art that goes on into a data science process. So you might want to highlight those things.
All right, we'll move on to the next question. It looks like it's the last question. If anyone has any other questions, you can send them in the chat. But we have this question from Anand. He's asking, do you have to be a domain expert in a particular field to become a data scientist?
The quick answer is no. You will see a lot of consulting companies, by nature, they jump from client to client, right? Some of them stay in a particular industry, but many data scientist roles are, housed in consulting companies where they're having to go to a new client and get up to speed really quick, learn it, and build just as effective algorithms. So you do kind of need the flexibility to learn pretty quickly. But that said, as a data scientist, what you have to focus on when you are first learning about that domain is asking a ton of questions with an expert in that field to say, well, what's the objective of this business problem? What is the risk if this model gets the answer wrong? Is it, sanctions and millions of dollars in fines, or customer just doesn't buy that product, so there's a little bit of room for error, right? You have to kind of understand what the use case is and how that's going to how that model is going to be exposed to a customer, or how that's going to be used in the outside world, and learn all about the implications of what that algorithm is potentially going to do. So you absolutely don't have to be an expert in that domain, but you have to do your due diligence, at least within that problem context, to find out everything that you can about what it means to have a data, driven solution in that space. I hope that made sense.
Yeah, okay, he said thank you. Does anyone else have any other questions? Okay, so we have a question from Anita. So she says, I am a software quality assurance analyst and looking into learning more about data analytics. Does this mean I need to learn more Python and R?
So when you say data analytics, it's more than just about machine learning. Data analytics is such a big field. There's data visualization, there's business intelligence, there is, automation of reporting, there is statistical forecasting. So there's so many things that you can explore. So in that case, you don't necessarily have to know Python and R. There's so many tools around business intelligence and data visualization that you might want to also learn, like Tableau or something like that. But if you want to get into machine learning, yes, I would say if it comes down to Python and R, you want to learn Python. And so Python will, in terms of Python, you want to learn how to manipulate your data, probably using something like pandas. And then in terms of the algorithms, there's a lot of different packages that you can explore with, but it comes the functions come predefined where you're, for the most part, you're able to just kind of feed in some data and get some output and things like that. So in short, yes, you want to learn Python.
Alright, cool. If anyone else has any other questions, you can send them in the chat or unmute yourselves.
Thank you, Mimi. I am not a college student, actually. Can you hear me?
Yes, I can.
I'm not a college student. I am just a regular person that worked at Sabre and got furloughed. So now I'm looking for other opportunities. So I am learning a lot of different programming languages currently. So that's why I've been attending, there's a meetup group or something, and I get all these emails. So that's why I attended your session, which is very informative and very, very good. I appreciate that.
You're welcome. Yeah, I'm glad you were able to join us. I didn't know we had such a diverse set of attendees, so it's great meeting you. And yeah, unfortunately, the travel industry has been impacted greatly, so I'm sorry to hear that. But it seems like you're, being super proactive about, your next opportunity. So I wish you the best of luck.
Thank you. I'm the only old person in here. Sorry.
You got me.
I'm older than you, darling. But thank you.
Thank you for coming. Okay.
Yeah, okay. Okay, well, I think that's it with the questions. And so, thank you, Mimi, for having this workshop with us. We learned a lot, and it was really informative. And thank you, everyone else, for attending. I hope you guys enjoyed it just as much as I did.
Thank you for having me. I really enjoyed it, and made me think a lot about how to, talk about it, and gave me new ideas and, different ways to think about this field. So I really appreciate this opportunity.
Yeah, of course. Thank you so much. Okay.
All right.
Bye.
Have a good evening. Bye-bye.